In this week's problem, we're looking for a 7-digit palindromic number. Palindromes appear the same forwards as they do backwards. Here are some common names that are palindromes. There are 4 people listed in the phone book with this name. If the narrator's parents had gone in that direction, his name would be Thurgniak Canwright. And then there's actor Robert Trebor, but further examination reveals that his given name was Robert Schenkman. Here's a common palindromic sentence. And another. And another. And yet another. But let's get back to this week's problem. We use variables for each of the 7 digits. But since it's a palindrome, the last 3 have to be the same as the first 3. And then the last digit is 3 times the second digit. So we change it to 3b. And then the first digit gets changed to 3b because the first and the last are the same. And of course the middle digit is the third digit minus the 6th digit, or C minus B. And then we realize that to multiply by 3, the only digits that multiply by 3 so that the result is a single digit are 1, 2, and 3. And then we look at the top group that starts with 3, 1 and ends in 1, 3, and we realize that since they all have to add up to 41, the middle 3 digits would have to add up to 33, and that's impossible. So we cross it out. But then we put a 9 in for C in our middle combination, and then C minus B would be 7. We add those 7 digits up, and we get 41, so we have an apparent answer. And then trial and error rules out any other apparent answers. So here's our answer, 6,297,926, the answer to this week's problem of the week.